हेलो स्टूडेंट्स, सो टेस्ट 75 का डिस्कशन स्टार्ट करते हैं। ओवरऑल पेपर को मैं इजी साइड पे बोलूँगा। 27 क्वेश्चंस को मैंने इजी कैटेगरी में मार्क किया है एंड मीडियम डिफिकल्टी मॉडरेट डिफिकल्टी लेवल 11 क्वेश्चंस का है एंड 7 क्वेश्चंस डिफिकल्ट हैं एंड 7 क्वेश्चंस में 3-4 क्वेश्चंस को मैंने एक्चुअली कैलकुलेशन की वजह से डिफिकल्ट कैटेगरी में डाला है, अदरवाइज कॉन्सेप्ट ये सॉल्वेबल है ना। तो 145 प्लस इज़ अ गुड स्कोर। हम आगे प्रोसीड करते हैं। तो फर्स्ट क्वेश्चन हम लोग देखें। The age of the wood if only 1/16th part of the original C14. The age of the wood if only 1/16th part of the original C14 is present in its piece is. So 1/16th, that means 4 half lives. Okay, n is n naught upon 2 raised to power t by t half, and that is equal to n naught by 16. That means t by t half is equal to 4. So t is 4 times t half. So 5580 into 4. So 5580 into 4. So that is 22320 years. Next question. The wavelength involved in the spectrum of deuterium are slightly different from that of hydrogen spectrum. तो ये ऑब्जर्वेशन है. सो गाइज एक्चुअली हम मानते हैं कि न्यूक्लियस का मास बहुत मैसिव है एंड इलेक्ट्रॉन इज रिवॉल्विंग अराउंड द न्यूक्लियस. But in actual, both nucleus and electron revolve around their common center of mass. So if we incorporate the mass of nucleus, in that case, radius will be n square by z h square epsilon naught upon pi mu e square. Okay, this mu is called reduced mass, which is mass of revolving electron into mass of nucleus upon me plus mn. All right, so we ignore this mass of nucleus. Now in case of deuterium, mass of nucleus will be greater, so mass of nucleus will be greater, so that's why the wavelength, the radius, energy all will be different. So mass of the two nuclei are different. Okay, bomb of mass 30 kg rest explodes into two pieces. The velocity of 18 kg mass is this, a kinetic energy of the other mass. So momentum is conserved. So 0 initial momentum is equal to 18 into 6 plus 12 into minus v. So v is 9 meters per second. Okay, 12 6 2s are 12, 2 9s are, so that is 9 meters per second. Now kinetic energy of the other mass. So kinetic energy of the other mass, which is 12 kg, is half into 12 into 9 square, so that is 81 into 6, so that is 486 joules. A machine gun fires a bullet of mass small m with a velocity of this. The man holding it can exert a maximum force of this. So if n bullets are fired per second, then the impulse imparted to the gun per second, which is the force acting on the gun, is nmv. So small n is f upon mv. So f is 144, mass is 40 into 10 to the power minus 3, and v is 1200. So 0, 10 to the power minus 3, 100 cancel, and 12 4s are 48, 48 3s are 144. So number of bullets is 3. So C is the correct option. A simple momentum, its acceleration vector when it is less than, displacement is less than the maximum. So when the displacement is less than the maximum, both radial and tangential acceleration will be present. Okay, radial acceleration will be directed towards the center, the radial acceleration, and tangential acceleration is along the tangent. So net acceleration is in between. So correct option is C is the correct option. Okay. Particle P is moving in a circle of radius r with uniform speed v. C is the center of the circle and AB is the diameter. So let's say particle is moving in this circle. Okay, this AB is the diameter and C is the center of the circle and P is the moving point. So P is the moving point. So the angle subtended by the position vector of P relative to the center at C, this angle is theta, and relative to A, this angle is theta dash. So from properties of triangle, we know angle subtended by an arc at the periphery is half of the angle subtended at the center. So theta dash is actually theta by 2. So d theta dash upon dt is half of d theta by dt. So the angular velocity of P about A, so omega of P about A is half of omega of P about C, that is omega by 2. So ratio is 1:2. So B is the correct option. Angular velocity about A is half of that, which is about C. Now next, 6 resistances, the resistance will be maximum between. So we need to calculate the resistance across each of the two ends. Okay, so first we calculate PQ. So resistance across PQ. So for PQ, R by 3 and R by 2 are in series, and then they are in parallel with R. So R by 3 plus R by 2, and they are in parallel with R. So that is 5R by 6 into R upon 5R by 6 plus R. So that comes out 5R by 11. So resistance across PQ is 5R by 11. Similarly, you calculate resistance across QR. So resistance across QR, in that case R and R by 3 are in series. So 4R by 3 into R by 2 upon 4R by 3 plus R by 2. So this is 4R by 3, which is 4R by 11. This is 4R by 11. Now R across PQ we have calculated, QR we have calculated, now PR. So R across PR. So now R and R by 2 are in series, and then they are in parallel with R by 3. So R and R by 2 are in series. So 3R by 2. So 3R by 2 into R by 3 upon 3R by 2 plus R by 3. So that is 3R and 339 plus 211. So that is 3R by 11. So we see across PQ resistance is highest. Okay, across PQ. Galvanometer of resistance 20 ohm, 22.8 ohm measures 1 ampere. How much shunt should be used so that it can be used to measure 20 ampere? So when an ammeter reads at its full scale, the current flowing through the galvanometer is Ig. So through the shunt it is Im minus Ig. So G into Ig is equal to Im minus Ig into shunt. So the value of shunt is G into Ig, that is 22.8 into 1 upon Im minus Ig, that is 20 minus 1, 19. Okay, so 19 ones are 19 and 19 twos are 38. So this is 1.2 ohm. So simple calculation thing. The ratio of the magnetic field at the center of current carrying circular coil to its magnetic moment is X. If the current and radius each of them are made 3 times, the new ratio will be. So magnetic field at the center and the magnetic moment. So B at X barabar 0 upon magnetic moment. So B at X equals 0 is mu naught Ni upon 2R, and magnetic moment is Ni into area, which is pi r square. So Ni cancel. Okay, so this is proportional to 1 upon r cube. Now this ratio is given X. So X is proportional to 1 upon r cube. So when radius is tripled, X dash is X by 27. So D is the correct option. In an LCR circuit, the capacitance is made 1/4, and when in resonance, what should be the change in inductance? So the circuit still remains in resonance. Okay, so omega is 1 upon root LC. Okay, so now you have made capacitance 1/4. So inductance should be 4 times. So product of L and C remains same. So A is the correct option. If each capacitor has capacitance C, then the equivalent capacitance between A and B. All right. So we are observing that outside the points are connected, outside terminals are connected with wires. Okay. So let's mark the junctions. Say this is junction 1, 2, 3, 4, 5, 6, 7 and 8 and C. this is A point and this is also A point, since they are connected with plain wire, so both have same potential. This is also A point, this is also A point. Okay, so one method is कि we redraw the circuit. So if we redraw the circuit, we are observing due to this A and C, 1 3 4 6, they are at the same voltage. 1 3 4 6 and A 1 3 4 6, 1 3 4 6 A, they are at the same voltage. And similarly, due to the symmetry, 2 8 7 5 are at the same voltage. 2 8 7 5, they are at the same voltage, and B is the end point. Okay, so let's redraw the circuit. So let's connect between 1 and 2, there is a capacitor. So between 1 and 2, there is a capacitor. Between 2 and 3, there is a capacitor. 2 and 3, there is a capacitor. 3 and 8, there is a capacitor. And 2 and B, there is a capacitor. 2 and B. 1 and 7, 1 and 7, we have a capacitor. 7 and 6, 7 and 6, we have a capacitor. 5 and 6, we have capacitor. 5 and B, this is 5 and B. 8 and B, 8 and B, and 8 and 4, 8 and 4, and 7 and B, 7 and B, and 4 and 5, 4 and 5. Okay, so we have covered all the capacitors. So here there are 8 capacitors in parallel, and here there are 4 capacitors in parallel. So we have 8C and 4C in series. So C equivalent is 8C into 4C upon 8C plus 4C, that is 32 by 12, which is 8C by 3. So this is one of the methods. Second method is like we are observing due to the symmetry, 1 and 3, 7 and 8, and 6 and 4 have same voltage. 1 3 7 8, I mean we are observing alternately we are observing V1 equals V3, similarly V7 equals V8, and V4 equals V6. Okay, and similarly V2 and V5 are also equal. V2 and V5 are also equal. So we can flip the circuit, such that across the line 2B5, we can flip the circuit. So the circuit then reduces. When we flip the circuit, this circuit reduces. So this is C, this is C, this becomes 2C, 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 and this is B point, and this is A point. This is A point. Okay, now again see, this is 8 and 7 overlap, 8 and 7 overlap, 4 and 6 overlap, and similarly 1 and 2, 1 and 3 overlap. Okay, this is 2 point and this is 5 point. Now again, as 1 3 4 6 are at the same voltage. Okay, so we can again flip the circuit across this line. We can again flip the circuit across this line. So in that case, this is 2C and this becomes 4C. This is 2C and this becomes 4C. Okay, 2C, 4C, 2C, 4C, and here it is B point and here it is A point. So this is 8c by 6, this is 8c by 6, so 8c by, sorry, 8c by 6, yes, 8c by 6, 8c by 6, okay, so they are in parallel, 8c by 6, 8c by 6, that is 16c by 6, so C equivalent is 8c by 3. So in this manner we can also calculate the C equivalent, okay. Uniform electric field, so we are to relate, uniform electric field is in plus x direction, okay, this is in plus x direction, and this is origin, this is positive x, this is positive y. So A is at the origin, A is at the origin, B is at x 1 comma 0, and C is at 0 comma 1. So we know in the direction of field potential decreases, and normal to the direction of field potential remains same, okay. So VB is less than VA, and VA and VC are equal. So VB is less than VA, so VB is less than VA, B is the correct option. Semi-major axis of the orbit of Saturn is approximately 9 times the time period of revolution. So we know time period is proportional to r raised to power 3 by 2, where r is semi-major axis. So T dash upon T is 3, semi-major axis is 9 times, so 9 raised to power 3 by 2, that is 27. So time period of Saturn is 27 years. Spring balance A and beam balance B are used to weight the same object. So spring balance will measure weight, which is dependent on G. So readings will be different at equator and pole. And beam balance, actually G cancels out because we measure torque. So M1G is equal to M2G. So G cancel out. So the reading will not be affected when we switch from equator to pole. So reading of A will be different, but B will be same. So reading of A will be different, but those of B will be same. So B is the correct option. So B is the correct option. B is the correct option. Next. When an ideal diatomic gas is heated at constant pressure, the fraction of heat energy supplied which increases the internal energy of the gas is. So delta U upon Q is NCV delta T. NCV delta T. NCV delta T upon NCP delta T. So that is 1 upon gamma. Now for diatomic gas, gamma is 7 by 5. So 7 by 5. So it is 5 by 7. Okay. Certain amount of an ideal gas is contained in a vessel. The vessel is moving with constant velocity v. The molecular mass is there. The rise in temperature of the gas when the vessel is suddenly stopped. So when vessel is suddenly stopped, the kinetic energy of the gas, the kinetic energy, the translation of kinetic energy goes into random energy, into the internal energy. So half capital M V square. This was the kinetic energy before the container was stopped, and now this gets converted into internal energy. So N CV delta T. So the rise in temperature delta T is capital MV square upon 2 N CV. Okay. Now CV is MV square upon 2N. CV is R upon gamma minus 1. So R upon gamma minus 1. So MV square gamma minus 1 upon 2R. Number of moles we should take 1. So MV square gamma minus 1 upon 2R. Next question. An ideal gas heat engine is operating between TC and TH and TC. It absorbs H of heat at the higher temperature. The amount of heat converted into work. Okay. So W upon QH is 1 minus TC by TH. This is efficiency. So W is QH, which is 10 to the power 4, 1 minus TC, which is 273 plus 127, 400, and TH, which is 273 plus 227, which is 500. So 1 by 5. So that is 2000 joule. So A is the correct option. A coil in the shape of an equilateral triangle of side L is suspended between two pole pieces of a permanent magnet such that the magnetic field B is in the plane of the coil. The current is I, then the torque. So magnetic field is in the plane of the coil, that means it is at an angle of 90 degree with area vector. So torque is magnetic field into I into area into sine 90 degree, that is B into I. Area is root 3 L square by 4, half AB sine 60. So root 3 L square by 4, this is area, sine 90 is 1. So L is 4 tau upon root 3 IB whole under root. Now this is 2 tau upon root 3 IB whole under root. So A is the correct option. The magnetic field due to a current carrying circular loop of radius 12 at center is this. Field at a distance on the axis is. So B on the axis upon B at the center is mu naught Ni r square upon 2 r square plus x square to the power 3 by 2. This is on the axis, and the center, this is mu naught Ni upon 2r. So mu naught Ni by 2 cancel, and this is r cube upon r square plus x square to the power 3 by 2. So B at the axis is B at the center, which is 0.5 into 10 to the power minus 4, and r cube, that is 12 into 12 into 12, and r square plus x square under root is 13, 12 square plus 5 square under root 13, so 13 into 13 into 13. Okay, roughly we take 12 by 13 to be 0.9, so 0.5 into 0.9 into 0.9 into 0.9 into 10 to the power minus 4. So this is 0.45 into 0.81 into 10 to the power minus 4. So 0.8 into 0.4 is 0.32. So 0.32, so 3.2 something into 10 to the power minus 5. So A is the correct option. So a bit calculative. Magnetic moment of electron. So magnetic moment of orbiting electron, L is magnetic moment, M by L is Q by 2M. So E by 2M into L, that is E by 2M, and L is NH by 2 pi, so proportional to N. So magnetic moment is quantized, that is proportional to N. D is the correct option. Two trains A and B are moving in parallel tracks with uniform speed in the same direction with A ahead of B. The driver of B decides to overtake A and accelerates at this after 50 seconds. So let's say this is train B with ahead of B, train A, this is train A, okay, and this is train B, okay. So this is if after 50 seconds the guard of B just brushes past the driver of A. So this is guard of B and this is the driver of A. So separation between them is, say, D. Okay, so let's solve the problem for in the frame of train A. So with respect to train A, u of B relative to A is 0 because both have same speed, and acceleration of B relative to A is 1 meter per second square, and delta x of B relative to A is D. Time is given 50 seconds, so delta x BA is equal to UBA T plus half ABA T square. So D equals 0 plus half ABA, which is 1 into T square, which is 2500. So this is 1250 meters. So separation between guard of the train B and driver of train A is 1250 meters. This is the question in the NCERT exercise. A boy playing on the roof of a 10-meter high building throws a ball with a speed of this at an angle of this with the horizontal. The distance of the ball in the same horizontal plane of the point of throw. So this is, language is a bit confusing. The distance of the ball in the same horizontal plane of the point of throw. So this is the top of the building and the boy throws the ball. This follows this parabolic trajectory. Now this is the horizontal plane passing to the point of throw. So we are asked actually OA. So we know this is range. We can apply the formula u square sine 2 theta by g. So u square is 100, sine 60 is root 3 by 2 upon g, which is 10, which is 5 root 3 meters, so 8.66 meters. 3 blocks, then a tension T2. So tension T2 is M2 plus M3 into A. We have considered M2 and M3 separately, and A is F upon total mass. So F upon M1 plus M2 plus M3. So now substituting the values, M2, M3, 10, and M1 plus M2 plus M3, 20. F is 40, so that is 20 Newton. So B is the correct option. Mass of 1 kg is suspended by a thread. Lift is accelerated up, lowered down, the ratio of tensions. So when it is accelerated up, tension is mg plus A, and when it is accelerated down, tension is mg minus A. So ratio T1 upon T2 is g plus A upon g minus A, that is 9.8 plus 4.9 and 9.8 minus 4.9. So this is 3:1. Using the following data, mass of hydrogen, mass of neutron, mass of nitrogen atom, calculate the value of binding energy. So binding energy will be mass of reactants minus mass of product into C square. So suppose Z protons combined, so Z into mass of proton, A minus Z neutrons combined, so A minus Z mass of neutron, and minus mass of nucleus into C square. This is binding energy. Okay, so ZMP, so 7 into 1.00783 plus 7 mass of neutron, which is 1.00867, minus capital M, which is 14.00307 U, and into C square, so that is 931.5 mega electron volt. So this is 14.11550 minus 14.00307. I would advise to leave the question unless you have sufficient time in the exam left. You should leave this question because it's a bit calculative, and 104, 112 are very close options. So this is 0.11243 into 931.5, so approximately 104. So I think you should leave the question in first go. 65 Cu will turn into 66 Cu. So mass number is increasing, atomic number is same, so it should be bombarded with neutron. So B is the correct option. If a simple pendulum oscillates with an amplitude of this and time period this, then its maximum velocity. Since time period is given, that means this is simple harmonic motion. So with small amplitude, so we can approximate it with linear SHM. So maximum velocity Vmax is omega A, that is 2 pi by capital T into A. Okay, so 2 pi by capital T is 2 seconds, and amplitude 50 millimeter, so that is 0.05 centimeter, 0.05. okay, so 3 into 0.05, so that is 0.15, so 0.15 meters per second. Cylinder tube open at both ends if the one of the ends is closed. So when open at both ends, frequency is V by 2L, and when closed at one end, frequency of fundamental is V by 4L. So F2 is F1 by 2. So if one of the ends is closed, the fundamental frequency will become 1 by 2, N by 2. The de Broglie wavelength of an electron accelerated to a potential difference of 400 volt. So lambda is H by P, which is H upon root 2 km, bit calculative, otherwise concept is easy. 6.6 into 10 to the power minus 34, and 400 electron volt, so 2 into 400 into 1.6 into 10 to the power minus 19, mass of electron, which is 9.1 into 10 to the power minus 31. First let's settle the exponent. So 10 to the power minus 31, 10 to the power minus 19, that is 10 to the power minus 50, and into 10 to the power minus 50, so 10 to the power minus 25, so 6.6 into 10 to the power minus 9. Now in denominator, 9.1, so 3, and 16, 4, 2 and into under root 20. So 3 4s are 12, 12 2s are 24, 24 3s 24 2s are 24 2s are 48, and then 48 8 56 66 80, 24 6 are 144, 24 7s are, so 24 7s are, so it is 0.275 approximately upon under root 20 into 10 to the power minus 9. This is 0.275 under root 20 is 4.5 into 10 to the power minus 9. So that is 275 upon roughly 275 upon 4500 into 10 to the power minus 9. So this comes out roughly 0.06 into 10 to the power minus 9. Okay, so this is D is the correct option. All right, so let's move to the next question. If the photoelectric emission process from metal work function is this, the kinetic is the most energetic electrons, the corresponding stopping potential. So stopping potential is corresponding to the maximum kinetic energy. So that is 0.5 eV. So stopping potential is 0.5 V. So C is the correct option. Two mercury drops merge to form a bigger drop, the surface energy. So when n drops are merged, from volume conservation we get capital R to be equal to n to the power 1 by 3 small r. So radius of the bigger drop is 2 raised to power 1 by 3 into small r. So surface energy of bigger drop is 4 pi capital R square T, which is 4 pi capital R square, which is 2 raised to power 2 by 3 small r square T. Now this is 2 square into 2 raised to power 2 by 3 pi r square T. So that is 2 raised to power 8 by 3 pi r square T. So D is the correct option. A U-shaped wire is dipped in a soap solution. The film formed between the wires and light supports a weight of this. So this is U-shaped wire frame, and this is slider, and this is supporting weight W. Now force due to surface tension is twice of SL and weight is mg. So twice of SL is equal to mg. So we have to calculate surface tension. So S is mg upon 2L. Now mg 1.5 into 10 to the power minus 2 and 2L, so 60 centimeter, so 60 into 10 to the power minus 2. So that is 1.54 1 by 40 Newton per meter, 1 by 40 Newton per meter, that is 2.5 into 10 to the power minus 2 Newton per meter. So D is the correct option. Consider the shown glass slab having a thin biconvex cavity. So see, outside refractive index is N1 is 3 by 2 and inside N2 is 1. So since N2 is lesser than N1, so lens will behave as diverging lens. Therefore the image will be virtual and between O and P. So on the left side, and the distance should be lesser than 3.5 centimeter. So there is only one option, 3.75 centimeter on the left side of O. Okay, so now let's calculate it. So 1 by F, let's calculate focal length that is N2 by N1. So N2 is 1 upon N1, N2 by N1 minus 1, 1 by R1 which is 10 minus 1 by R2 which is minus 10. So this is minus 1 by 3 and this is 1 by 10 plus 1 by 10, 2 by 10. So this is minus 1 by 15 centimeter, 1 upon F. Now 1 by V minus 1 upon U is equal to 1 upon F. So 1 by V is 1 by U, 1 upon U which is minus 5 plus 1 by F which is minus 1 by 15. So this is minus 4 by 15. So V is minus 3.75 centimeters. So without calculation we could have also predicted the answer. A ray of light is incident on a surface of glass slab at an angle of 45 degrees. The lateral shift produced per unit thickness. So guys, I would recommend you to learn the formula of lateral shift when the ray is incident at an angle I, this is the original direction of propagation. Okay, this angle is I. Now ray shifts towards normal. This is angle R, and from here it goes parallel to the incident ray. So this is the shift produced. This is shift. Okay, and slab thickness is T, then the shift is T upon cos R into sine of I minus R. I would advise you to learn this formula. Okay, so shift per unit thickness. So shift per unit thickness, that is 1 upon root 3. Shift upon T is 1 upon root 3, and sine of I minus R, if, then the angle of refraction. So sine of 45 degree minus R upon cos R. So 1 by root 3. Now sine of A minus B is sine A cos B minus cos A into sine B upon cos R. So this is sine 45 cos 45 1 by root 2. So root 2 by 3 is equal to 1 minus tan R. So tan R is 1 minus whole under root 2 by 3. So R is tan inverse 1 minus whole under root 2 by 3. So B is the correct option. A thin horizontal circular disc is rotating about a vertical axis. An insect is at rest point near the rim of the disc. So this disc is rotating about the axis. Now when the insect will move along the diameter from A to B, angular momentum, which is I omega, is constant. So as the insect moves from A to B, I first decreases, then increases. Accordingly, omega first increases, then decreases. So C is the correct option, angular momentum conservation. The average value of rotational kinetic energy is the 1 mole of oxygen gas. So oxygen gas, rotational kinetic energy have 2 degrees of freedom, and for each degree energy per mole is half RT. So rotational kinetic energy per mole is twice of half RT, that is RT. So A is the correct option. In common emitter transistor amplifier, beta is this, RO is this, RI is this, the voltage amplification. So AV is beta into RO upon RI. We can calculate AV. Current flowing in each of the following circuits. So both the diodes in first figure are in forward bias. So current in the first circuit is 8 upon 2 ohm, that is 4 ampere. And in the second circuit, the lower diode is reverse biased. So I2 is 8 upon 4 ohm, that is 2 ampere. So 4,2, C is the correct option. Brass wire is held taut with negligible. If the wire is cooled to this, then the tension developed in the wire, its diameter being this. So thermal stress, okay. So change in length because of stress produced plus change in length because of change in temperature is 0. So FL upon AY plus L alpha delta T is equal to 0. So F is minus AY alpha delta T. You may remember this formula. The tension produced due to cooling or heating is minus AY alpha delta T. So minus A, area, pi r square. So pi r square, diameter is 2 millimeter. So radius is 1 millimeter square, so 10 to the power minus 6. Y 0.91 into 10 to the power 11. So 91 into 10 to the power 9. Alpha, which is 2 into 10 to the power minus 5. And delta T 27 to minus 33. So that means change is minus 60. So minus 60. Okay. So 10 to the power minus 6, minus 5, minus 11. And this is 10 to the power 9, 10. So 10 to the power minus 1. So minus plus pi into 10 to the power minus 1. Now 6 2s are 12, 91, 12 into 91, 12 9s are 108. So this is approximately 1080. So 1080, 10 to the power minus 1, 0 cancel, 108 into 3.1, so roughly 108 into, so roughly 324 roughly, so that is 0.34 kilonewton. So C is the correct option. Identify the pair whose dimensions are same. So torque and work have same dimensions, force into length. A system of two polarizers, from the second polarizer is half from that of the first polarizer. So we know from Malus law, I2 is I1 cos square theta, and that is I1 by 2. So theta is pi by 4. So 45 degrees answer. Two slit, lambda is given, small d is given, capital D is given, plate thickness is given, and shift is given. What is the refractive index? So shift is n minus 1 t capital D upon small d. Okay, so n is shift small d upon capital D t capital D plus 1. So shift is given, shift is it is found that the interference pattern shifts by 5 mm. So 5 into 10 to the power minus 3. Small d is given 2 millimeter apart, and thickness of the plate is 0.5 mm. So 5 into 10 to the power minus 4, and capital D is given 10 centimeters. So 10 to the power minus 1 meter plus 1. So 10 to the power minus 5, 10 to the power minus 5, 5 2s are 10 upon 5, just 10 to the power minus 5, 10 to the power minus 10 to the power minus 1. So this is 0.2 plus 1, so that is 1.2. 43. Closed pipe and open pipe have the same first overtone frequency. So for a closed pipe, first overtone frequency is 3V by 4L closed, and for an open pipe, first overtone frequency is V upon 2V upon 2L open. So their lengths are in the ratio. So LC upon LO is 3 by 4. So 3:4 is the correct option. Progressive wave, how far away are the 2 points having a phase difference of 90 degree? So delta phi is K delta L. So delta L is delta phi is pi by 2 upon K. K A sin omega t minus Kx is K is 4. So pi by 8 centimeters. So C is the correct option. A bead of mass M, horizontal ring of radius 3r, and so BC is 3r. BC equals AC. BC equals AC equals 3r. Natural length of the spring is r, and the initial length OA is 4r ka square plus 3r square whole under root, so that is 5r. So length of the spring in OA orientation is 5r, natural length is r, so initial deformation is 5r minus r 4r. And final deformation, when the bead comes to point B, it comes in natural length, spring comes in natural length, so x final is 0. So loss in elastic potential energy goes into kinetic energy. So then the kinetic energy of the bead, so delta K is loss in potential energy, so half K into 4r square, that is 8K r square. So that's all for today.